So, how do we know if something is actually, truly real? It's a huge question, right? But believe it or not, there's a systematic way to find an answer. Today, we're going to walk through that exact process, the whole research journey, from asking a simple question to landing on a solid conclusion. Let's dive in.
Everything, and I mean everything, starts with a question just like this one. How do you separate a lucky guess from something that's a proven fact? Well, that's the whole point of research, really, to get as close to the truth as we possibly can.
Okay, to make this all feel a bit more concrete, let's use an example we can follow throughout this whole thing. Imagine you've launched a new product, right? And crickets. Sales are totally flat. Now, you could just guess and start throwing money at random solutions, or you could use a step-by-step process to find the real problem. And that's exactly where we begin.
So what is this process? What is research really? Well, at its heart, it's just a systematic way to answer questions. But as you're about to see, not all research is trying to do the exact same thing.
It turns out, research kind of comes in two main flavors. On one side, you've got basic research. This is all about expanding our knowledge just for the sake of it. Like a physicist studying weird subatomic particles just to see what's there. But on the other side, there's applied research, and that is exactly what our struggling product needs. It's designed to solve a very specific, real-life problem right now.
So, before you can test anything, you need an idea that you can actually test. And that's called a hypothesis. Now, this isn't some wild guess you pull out of thin air. It's your best, most educated guess based on what you already know. For our product, a good hypothesis might be something like, our new ad campaign will increase sales. Simple, clear, and testable.
Okay, now here's a cool thing. Every hypothesis has a skeptical twin. The alternative hypothesis, that's your exciting idea. It's what you think is going to happen. But you have to test it against its boring twin, the null hypothesis. The null basically says, nothing's going on here. The ads won't do anything. Your entire job as a researcher is to find enough powerful evidence to prove that boring, null hypothesis wrong.
All right, you've got your hypothesis. Now what? You can't just start grabbing people off the street and asking them questions. You need a plan, a master plan. This is your research design, and it's basically the blueprint for your entire study. The very first piece of your plan is figuring out your independent variable. Just think of it as the cause. It's the one thing that you, the researcher, are going to change or introduce to see what happens. In our case, it's pretty simple. It's the new ad campaign.
So, if the ad campaign is the cause, then what's the effect? Well, that's your dependent variable. Its outcome depends on the independent one. For us, it's super straightforward. We're measuring the sales figures. After the new ads run, did sales go up, down, or stay exactly the same?
With a solid plan in place, it's time for the really fun part, actually collecting the data. This is where you get to go out into the real world and start gathering the clues you need to see if your hypothesis holds up.
One of the most common ways to gather these clues is by using a survey. You're basically asking a specific group of people some questions so you can understand a much larger group. But here's the catch. The quality of the answers you get depends completely on the quality of the questions you ask. And here's a classic mistake to avoid: asking a loaded question. This is the kind of question that basically pushes the person you're asking toward the answer you want to hear. And when that happens, your data is totally biased and, honestly, pretty useless.
I mean, just listen to this one. Don't you agree? It's practically begging for a yes. A question like this doesn't measure what someone genuinely thinks. It just measures how much they want to agree with you. This is a perfect example of what not to do.
And here's another trap you got to watch out for: the double-barreled question. This is when you accidentally sneak two questions into one sentence, and it just creates total confusion for the person trying to answer.
Yeah, think about it. What if you're satisfied with your supervisor's work, but you're not particularly happy with them as a person, or vice versa? If you answer yes or no to this question, what does that even mean? It tells you absolutely nothing. You have to ask one clear thing at a time, period.
Now, of course, you can't survey every single one of your customers, right? That's impossible. So you survey a sample, a smaller group that is supposed to represent the whole bunch. Getting this sample right is absolutely crucial. If your sample is biased, your results are going to be biased, no matter how great your questions are. So, you've done it. You've gathered all your clues. You've got a big pile of survey responses, sales figures, maybe some interview notes. Now you have to actually make sense of it all. Welcome to the world of data analysis. Your data is usually going to fall into two big categories: On one side, you have quantitative data. That's all the numbers stuff. Sales figures, customer ratings from 1 to 5, percentages. It's awesome for explaining and proving things. Then you have qualitative data. This is the story stuff. Transcripts from interviews, customer comments, observations. It's fantastic for understanding the why behind all those numbers.
Now, when it comes to analyzing those numbers, you can go one of two ways. Descriptive statistics just, describe the data you collected from your sample. For example, the average rating from our survey was 4.2 stars. But inferential statistics, that's where the real magic happens. This is where you use that sample data to make an educated guess or an inference about the entire population.
Okay, you've analyzed your data, and you think you have an answer. You're feeling good. But how can you be sure your findings are actually trustworthy? This final step is all about quality control. The first big pillar of quality is reliability. It's a simple question. If you ran the same study again, under the exact same conditions, would you get the same results? Think about it. If your bathroom scale gives you a totally different weight every time you step on it, it's not reliable. Same thing goes for research. It has to be consistent.
The next pillar is validity. This one asks a slightly different question. Are you actually measuring what you think you're measuring? Let's go back to that scale. What if it's super reliable? It shows the same number every time, but it's always 5 pounds off. Well, then it's not valid. For our survey, are we really measuring customer satisfaction, or are we accidentally just measuring their loyalty to our brand? Validity is all about accuracy.
And finally, we have replicability. This is truly the cornerstone of the entire scientific method. Could another researcher, anywhere in the world, pick up your report, follow your exact steps, and repeat your experiment? If the answer is no, then your findings kind of exist in a bubble. Good research has to be transparent and repeatable.
And there you have it. That's the research journey, from a fuzzy problem to a solid evidence-based conclusion. It's so much more than just a process. It's a really powerful way of thinking. So, you now have the toolkit. The only question left is, what problem are you going to solve?